Hi, I'm Eric Wasti, and this is Advent of Code Behind the Scenes. Who let this guy on stage anyway? Well, I used to make large-scale web applications for ISPs, and I used to work on auction infrastructure. Now I do architecture for a trading card game marketplace. I also run some programming challenges like Advent of Code, which is probably why you're here. I make tools for games like Eve, League of Legends, Minecraft, World of Warcraft, some other things. I make fun of programming languages like PHP and JavaScript, and make lots of other random things that you probably haven't heard of, but we're not here for any of that. We're here for Advent of Code. What's Advent of Code? Let's back up a little. Suppose you are here. Sorry, that's small. Let me zoom in. Great. Suppose you are here, and all you have is a pen, a few napkins, a few weeks until Christmas, it's Halloween time, a random memory of advent calendars, and a passion for programming puzzles and helping people learn to become better programmers. The answer? Advent of Code. A combination of advent calendars and programming puzzles. So what are advent calendars? So, depending on your childhood and where you grew up, you may have encountered these things where there's little doors in this container, and you open up a door every day, starting usually early December, beginning of Advent, sometimes December 1st, it depends. And inside of each of one of these doors is a piece of candy or a toy or something like that, and you open them up and you're counting down the days until Christmas, and so every day you get some small thing that's fun. This is the one that I had growing up. Every day you take a little ornament out of the pouch, then put it on the tree and count down the days until Christmas. And so I made an advent calendar that looks like this, or this, or this. But where are the puzzles? Well, if you click on one of these numbers, you'll discover a puzzle inside, and every day contains a puzzle. And if you scroll down to the bottom, you can get an input file for some description of the puzzle. It talks about, elves and doing some stuff, and you get an input, and it has something that you're supposed to do with this file, and eventually you'll get an answer, and you put it in this box. And when you do that, it goes on to part 2, which has a twist or something. We'll get into that in a bit. And part 2 goes into, some variant of the puzzle or some harder version, or, goes on to some more interesting idea or some other concept. And eventually you fill in that answer and you get 2 stars for the day. Hooray! And as you finish all of these puzzles, the calendar fills up and you get some kind of cool picture. So, suppose it's 2015 and you just built a bunch of programming puzzles. Where should we host this thing? Well, let's see. Let's do some capacity planning. Programming puzzles probably won't be that popular. I've made some other systems, programs, applications, toys, websites in the past. My friends used them a little bit. Not a huge deal. Probably won't be that popular. They're kind of esoteric. Okay. I have a few friends that might like it, though. And they have a few friends that might like it. Maybe 50 people? But we're good systems engineers. We're good at capacity planning. Let's give us a wide margin to make sure that we can accommodate everybody. 70. That'll be enough. A small personal web server should cover it. Okay, so now it's November 30th, 2015. It's almost December 1st. It's time to launch the site. It's time to announce it. So you post on Twitter, and you tell everybody that you made this website about some kind of an advent calendar. It's coming out soon. And 27 people retweet it. Great. That's well within our margin of how many users we were expecting. Should be no problem. You look at the sign-up graph leading up until midnight, December 1st, 2015. And look at that. About 81 people signed up. We estimated about 70 people. That's still within tolerances. We can absolutely handle that. It's no problem at all. But then, the puzzle unlocked. And the graph did something that the technical term for this is, oh no! 12 hours later, the graph looks like this. Let me zoom out a little bit for you. There, that's a better. So that's 12 hours into the first day. That's the estimate we had, 70 people. That's 4,000. Okay, 70 people we hoped for, 4,000 people we actually got. That's an error of 5,600%. The small server is very sad. Okay, you're bad at traffic estimation. Now what? 2 steps. The first thing you should do, if you have a website that suddenly gets a ton of users and you weren't expecting it, turn off the Minecraft server. That freed up a significant amount of resources and gave us the breathing room to implement the real solution, which was don't create a new process to handle every request. Now, what? Why would I be doing that? Okay, so there's a very simple way to host very simple applications called CGI, stands for Common Gateway Interface. You create a process, the web server can talk to this process, the process can manage the stuff for the request. It gets some inputs, it gets via environment variables and standard in, it gets the request. Via standard out and standard error, it processes the request and gives a response and can put some things in the logs. These end up being the headers, the request body, the HTTP response, the log messages. It can also talk to databases, files, whatever it wants in the meantime. The problem is that it does this for every single request you get. If you have 70 users and you're making a new process for every request they're sending, that's no problem at all, and it makes prototyping and developing really, really fast and simple. If you have 4,000 users, do not use CGI. An emergency switch to fast CGI, where it keeps the same process alive that serves as many requests, managed to save the event. The server would have absolutely fallen over. So let's continue. 24 hours since unlock now. The graph sort of looks like this. That's our estimate of 70 users. That's 9,000. So hold on a second. Where did all these people come from? We just launched this thing to a couple of our friends. We posted it to Twitter where we had no followers. Who are all these people and why are they here? Well, can you see the error in my reasoning? It turns out these two lines I've highlighted are recursive. Because if they have a few friends that might like it, those people might have a few friends that like it, and then those people might have a few friends that like it. And this can end up being a serious problem if you suddenly find that word of mouth has caused your application's whatever it is to spread around the world, and all of a sudden you have people in every country talking about this thing that you made that you were expecting only a couple of your friends to do, and suddenly everybody on Twitter is posting about it. This was unexpected. 48 hours since unlock. The graph looks like this. There are 70 users. That's 15,000. Well outside of our tolerances. And by the end of December, we'll fast forward a little bit, 52,000 people ended up doing the puzzles on the site, which is mind-boggling. That's 2015. Shortly after that, we switched to AWS, which solved all of our scaling problems and has been completely excellent ever since. Today, we've had 730,000 people. 360,000 people have at least one star, so they've solved at least one puzzle. Which is mind-boggling. We're still growing. We're trending toward 1 million, which will be an incredible moment. I don't even know. There were also recently, with all of this scaling, some interesting problems in 2020. We had a pretty good grasp of the number of users that we would get based on the amount of traffic we were seeing, like in November. Excuse me. And the amount of like traffic that we were getting and the number of users that were accessing the site. And we can extrapolate roughly from how many users are hitting the site in November versus how much we're expecting to see in December. And based on a bunch of estimates for like database CPU utilization, web server CPU utilization, traffic throughput, things like that, we figured it would be totally fine. Turns out, we did not account for the amount of memory that individual worker processes take up, and we had no sane limit on the number of worker processes, and so all of a sudden the number of users that 2020 entailed, due to presumably people being stuck at home and wanting to work on something interesting, work on programming puzzles or something, all of a sudden the servers fell over because there were so many workers created that they saturated all of the memory and all of the machines, which caused all of the virtual machines to just like completely fall over, and a hard force stop from AWS wouldn't handle the problem. We handled that within a few minutes, but it kind of screwed up the day one unlock. There was also another issue that was kind of happening intermittently to a couple of users, but it was still a really interesting thing to track down. Turns out that elastic scaling things, like most AWS services, like AWS Elastic Load Balancers, which are excellent. This is not at all a knock on AWS. They've been very, very, very good. Turns out elastic things need time to scale, right? Even just seconds. ELBs in AWS, Elastic Load Balancers, will scale up to the level of traffic that they're seeing within seconds or minutes. They're very, very fast. The problem is that AWS traffic goes like this. 1 second before midnight, there are no users hitting the site. Midnight, all of the users are hitting the site. Midnight and 1 second, no users are hitting the site again. There is no time to scale. You just get all the traffic, and if you miss it, it's gone. So we had to work with AWS, who were excellent and jumped in and figured out our problem and managed to handle things immediately, to basically scale up our load balancers ahead of time and keep them scaled during the event so that we can handle the traffic without having to wait for the load balancers to figure it out. In a normal application, you get a couple users and the next minute you get a couple more, and it like ramps up over the course of the day, and then it goes back down at night, and it's a really good model for just like elastically following your traffic. Advent of Code does not do that. It has a single spike and that's it at midnight. I mean, during the day it does, but the midnight spike is the one that was falling over because none of the load balancers knew what was coming. So we pre-scaled the load balancers, and now we're figuring out other solutions, and it shouldn't be a problem next year. Hopefully, don't quote me on that. But that was a really interesting one. There's posts in the subreddit. If you look for post-mortem stuff in the subreddit recently, we talk about all of the different things we did in the research of how we got there. So, why do people do Advent of Code? What is this thing? So the goal is to give people a bunch of like practice problems to work on, a bunch of interesting little nuggets of like mini projects to work on. The original intent was if you're like somebody who's learning to program, right? And you read the documentation for like Python string reversal, and you're like, okay, this is how you reverse a string in Python or whatever it is, right? You'll never retain that because there's nothing you're applying it to. There's nothing you're tying it to. It's just like a feature that you now know the language has somewhere maybe. But if the problem says like, oh, there are some elves and Santa needs help fixing this database and it can only be uncorrupted if you reverse the strings between this point and then it'll be fixed. It seems like people retain that better when they're learning a language and when they're researching things in like language features or documentation. When they're doing it with a purpose, they tend to absorb it better. So the original goal was just like practice problems or fun things. But people also use it for interview preparation. Advent of Code puzzles tend to be very similar to some of the kinds of interview questions that people get, like whiteboard problems and that sort of thing, which is very good. It's become very popular for like company training, like engineering organizations will pick a couple puzzles throughout the year, or some group of people will do like one month every night they'll do Advent of Code puzzles, and then during the day they'll talk about them or something, and just like employee enrichment, those kinds of things. There is a ridiculous group of users who every night at midnight do it as a speed contest, which is completely nuts. The people that do the write at unlock who can solve it first contest are people that basically do competitive programming year-round nonstop, cut every corner, take every shortcut. None of their code is clean. They're not thinking about architecture. They just want the answer, and they get it very quickly. And it's incredible to watch them work, but it is a different thing than what I'm used to in software engineering. Or just, challenging friends with harder versions of puzzles. This is a really popular thing to do on the subreddit, where people will see a puzzle and they'll say, oh, this would have been way harder if, the input were larger, if the input had some property or whatever, and they'll create these versions of puzzles that have these properties that make them really interesting and post them, and all of a sudden everybody has this like part 3 version of the puzzle that was just like way harder that I didn't want to include on the site, or that I didn't even realize existed, that all of a sudden everybody gets to play with and try out. So just like stretching your knowledge and stretching your understanding. Also learning new languages, practicing existing languages, stuff like that. Just lots of reasons. So who are all these people doing Advent of Code? Well, they're all around the world. This is output from Google Analytics' like map view thing. And it's basically just like, if there are people in the country like with internet and doing software engineering, they show up on the map. Here's the map of the United States. Here's when it unlocks in those places, by the way. New York, where I am right now, it unlocks at midnight. California locks at 2100, 9 p.m. These are not bad times for people, typically. Midnight can be hard for some people. 2100 can get in the way sometimes, but Europe has it a little bit harder. In Europe, things are unlocking 5 a.m., 6 a.m., which for some people is a big problem, and some people just incorporate it into their morning routine. Here's somebody doing it in the shower on their way to get ready for work. Some people say waking up at 5 a.m. every day is not easy. Some people say nothing else can wake me up as reliably as Advent of Code did this month. I hear both. It's fine. People of all languages and all backgrounds do it. This is actually a pretty old picture. These numbers are much larger now. Any language you can think of, people are doing Advent of Code in it, just because it's a good way to learn new languages, or people will pick a language that's like either an esoteric language or one that they've designed or one that they're like working on at work, like some embedded language that they're working on at work, and use it as like a stress test, almost like a suite of like requirements and feature demands to see if the language can even tolerate those kinds of things. So lots of languages. People have solved the puzzles directly in hardware. That's an FPGA. It's like a programmable chip where you can tell the chip to be whatever chip you want and then implement a program in hardware and then run the program and get the result. Very, very cool. People from companies all around the world. Here's a picture of Facebook London's offices where they were posting their solutions on the glass wall on the other side of the stairs going up in a stairwell someplace so people could see them as they went up. That was a lot of fun. Or in universities, people will post their solutions on, like, this is the student union of, I forget what university this is, somewhere in Poland, I think, maybe, where as people do their solutions, they print them up here, and then people can walk past and see all the cool code that they've written and solutions that they've done. Non-programmers, people will just print out parts of the puzzle or do it on graph paper or work on it by hand or something like that. You don't necessarily need to be a programmer at all. As long as you have problem-solving skills, you can approach these problems any way you like. Excel is a popular one. Difficult, but, certainly doable. A few different people have done them in Excel in different approaches, which is a ton of fun to see. Literally just Gantt chart software. One of the puzzles was a topological sort. And if you just like toss this into a Gantt chart, it'll like produce the answer for you, which is really funny. Minecraft, lots of things like that. So let's talk about puzzle design a little bit. What does it take to make a good puzzle? Not Advent of Code puzzles necessarily. We'll get to those in a second too, but just puzzles in general. The first trick is avoiding ambiguity. It is really easy to express something in a way that seems like it makes sense in your brain as the author of the puzzle, but doesn't actually make sense at all, or where like the pronouns in a sentence can reference several different words and they're all equally valid interpretations, and it's all very confusing as to what it could be. This applies to like documentation and stuff too. If like you need to be very careful to make sure that there's a single obvious interpretation or a single correct interpretation that for any given sentence. Also, for puzzles especially, avoiding expectations of outside information. A lot of the people doing these puzzles have never taken a CS course. Or they might not have done, this is especially true for like whiteboard problems, they might not have the same domain knowledge as you. So it's really dangerous to ask like an interviewing whiteboard question that assumes that the person knows a bunch of things about your industry. You can't use like nouns from your industry that are obvious to you and your coworkers, but might not be obvious to the person that's applying for the job, something like that. Avoid requiring the users to make assumptions. So every time there's a place where you expect them to make assumptions, or there's like a deliberate point of ambiguity, or a deliberate point where two different things can be true, it basically requires them to like try every combination of all of those to see which one ended up being right, which is typically not the intent when you're doing one of these. It's especially good to repeat and highlight important details. I try to highlight keywords or key phrases. That way, just if somebody's glossing over the puzzle, hopefully they at least see those. And I've discovered that for every sentence, there is a user that skipped only that sentence. The dog barked, or they just like zoned out for a second or whatever. And all of a sudden, if there's some critical piece of information that appears in just one sentence, they will have missed it, and they'll need to either go back and find it or post asking for help or something like that. The best way to accommodate most of these things, to handle these sorts of situations, is to make sure that your brain isn't the only brain that processed the text of the puzzle. In my case, I have a bunch of beta testers that go through the puzzles, and if there's something that doesn't make sense to them or they feel it could be read multiple ways, we'll go back through and revise it a bunch of times until they think that it reads in a way that's consistent for them as well, just to try to catch things that, for me as the puzzle author, are obvious, but for them wouldn't necessarily be. So, for an Advent of Code puzzle in particular, I have a bunch of extra constraints. There's always exactly one correct answer for any given input. There's a whole bunch of different inputs. Each one of them has exactly one answer. So there's never a case where they're like, you need to give like the number of things, but it could either be this or this. There's always exactly one situation. Any language is valid, which means that all I'm looking for is the answer, some number or string or value that the puzzle describes, not give me your code and I'll boot up a container and run it and spit the thing out or something like that. Any language you want, you just give me what the solution is. There's lots and lots of different inputs. Generating those is its own puzzle, which I'll talk about in a moment. Every puzzle has two parts. Sometimes it's of a checkpoint puzzle format in which the checkpoint half, the first half, just makes sure that you parsed the puzzle correctly, or that you understand some fundamental property but doesn't actually have the really interesting part in it until you get to part 2 where the puzzle is, right? And sometimes it's a twist format where the first part is the puzzle that I originally intended to show off, the interesting part, and then part 2 is some twist on that either shows some other interesting thing or really, really cranks up the algorithm or asks you to run it a billion times or requires some optimization or scaling or something like that. But there's a lot of interesting things that you can do with two-part puzzles. They also are really useful because they help to simulate real-world engineering environments. There is no environment in which, well, typically, people will find exceptions, but in general, there are no environments where you write the code once and you are done and nobody ever touches it, right? Like that there's no maintenance and there's no user that has new things they want one day or something like that. Like, that's very unusual. So giving learners the opportunity to say, I've written this code, now what? And the answer is, well, now change it to do this other thing, exposes them to things that are very realistic, that gives them skills that are very useful when they get into the real world. It's very important to have a lot of variety. There are a lot of times where people are very divided on whether or not they like a puzzle. There are a lot of puzzles that some people really love and some people really hate. And rather than trying to make a puzzle that everybody loves, which is probably impossible, just make a lot of different puzzles so that one day if you don't like the puzzle, hopefully the next day you do. And then everybody can get something out of it and try something new. Difficulty calibration is also really important. It sometimes helps to have 3 or 4 puzzles that sort of talk about the same concept, that ask the same sort of thing, but do a simple version of it early in the month, and then 5 or 6 days later do a slightly harder version or a different way to look at it, and then a couple days after that do an even harder one, and then finally get into like the real concept that you wanted to apply originally, without starting with that, having everybody hit a brick wall. By the time they get to the harder puzzle, they don't even realize that they've familiarized themselves with it already. It's just all of a sudden they see this concept and they're like, oh yeah, I know how to do whatever it is. It's important to consider weekdays versus weekends. People have more time Friday night and Saturday night than they do Tuesday night when they have work in the morning. Variety. Variety is really important for difficulty. Everybody's different. Everybody has a different skill set. Everybody's been exposed to different concepts to different degrees. So if you have a whole bunch of very mathy puzzles, they'll all be hard to people that are not great at mathy puzzles. But if you have a lot of variety, then you can help to modulate the difficulty a little bit by making it so that if somebody found a mathy puzzle really hard, hopefully they're better at some other concept and the next day will be easier, or vice versa. Progression throughout the month. Start easier, work your way to harder, typically, roughly, but lots of other factors come into play, but something like that. Random off difficulty puzzles to control pacing. I like to have 1 or 2 hard puzzles earlier on if I can fit them in and it's reasonable to do. I like to have a couple easy puzzles late in the month so that people aren't just burned out by hard puzzles night after night after night. Just to shake things up and to give people something interesting. Also, interpreted versus compiled languages is really interesting because one of my goals with puzzles typically is to make it so that using any particular language or paradigm doesn't give you a runtime advantage. So if you're using Python or you're using C, the intent, hopefully, at least for the optimization puzzles, is that you can't just switch from Python to C and suddenly the runtime becomes reasonable enough to finish in a amount of time you'd be willing to sit there. The intent is that unless you get to the intended solution or the intended category of algorithms, the Python solution in the C program will always be slow. So if the non-intended category of solutions is brute force, for example, picking some input size where the C program even still takes weeks or years or whatever it is, but once you get into like the big O log n fast solutions, the Python solution is all of a sudden fast enough to do it in a couple seconds, and the C program is also. So regardless of whether it's interpreted or compiled, make sure that people can still have access to the same difficulty levels at the same time, based on run times and having to wait for things. So what does it take to actually make an advent of code puzzles? There's all of these inputs. Every user sees a different input. Like all of the users get distinct inputs. Like there's a finite number, but there's a lot, and they're pre-generated. So you take some inspiration, and usually the inspiration comes from some interesting nugget of things I've found when I'm working on some problem or some work or some whatever. Research that thing, see if it's actually interesting, see if it's a solved problem, see if it's an open problem, see if it's something that has some other neat twist to it or something like that, and then take all the things that I've learned and pull the most interesting bits out and just design a puzzle around it. Then build a program that spits out valid inputs for that puzzle that you've designed. Sometimes this process involves the input generator being very, very smart and always spitting out really good inputs. And then the part 1 and part 2 solvers, which are just solutions, just say, oh, okay, I've solved that, here's the answer, which it then records. Sometimes the input generator is really, really dumb, and it just says, I don't know, I just generated some random numbers, here you go. Lots of random numbers. And the part 1 and part 2 solvers say, okay, based on these random numbers, I'm going to solve the puzzle, but I'm going to check a whole bunch of assertions and assumptions to make sure that this input in particular happen to have whatever properties make this puzzle interesting. And sometimes it's a combination of both of those. So depending on what kind of puzzle it is, I have to spend different amounts of time on the input generator or on the solvers to make sure that the assertions are good, that the attributes of the puzzle are good, that every single input is fair, and that they're all even. That it's not like one input is significantly harder, or that requires some trick that the other ones didn't, or something like that. Then, use the generator and solvers to generate many inputs and get all their solutions, and then finally, write some prose that describes the puzzle in a cutesy way that involves elves or whatever the story is for the month, on top of all of the puzzle that you've written. So very often I won't even know what prose I'm going to be writing for the puzzle until after I've generated all of the inputs and all of the solutions. I'll create a puzzle and then I'll say, okay, what situation could this interesting thing be in? Oh, maybe it's like one this year was like, there was a kid sitting next to you that had a little handheld game console. Okay, maybe there's some bug with the console that I can work into this, and that's the puzzle or something like that. So figure out how that would fit in, write the prose, and then that's your puzzle. And you might think that the process for this is to go step for step to step to step to step and do all the things in order, and then you're done. But it actually looks like this. You write the thing, and then you figure out it's not really going to work, and then you have to go back and rework it, and sometimes that didn't work at all, and you have to go back to the research phase and figure out why it didn't, and then jump around. And it's very, you still get to the same answer, but there's a lot of steps. So let's do some example puzzles. Here's one that asks, how many square inches of fabric are within 2 or more claims? So this is a list of rectangles in a grid, basically. It gives you the top left coordinate and then the width and the height. And it says how many square inches of these things are in some kind of overlapping area of the rectangles. And it ends up rendering an image like this, where all of the lighter colored parts are overlapping. And then the second part is, okay, what is the ID number of the only claim, the only rectangle, that doesn't overlap with any other rectangle in the input? And I'll give you a second to look for it. Did you spot it? It's right there. Nope, nobody got it? Okay, that's fine. We'll move on. Here's another one. So one of the things that I've thought a lot about and worked on a lot about is just like log parsing. And so I wanted to include like a log parsing type puzzle just because I find that stuff to be interesting, and I hope other people do too. Also, it's probably something that people will encounter in engineering, and so it's a useful thing to have been exposed to. So this one is just a list of timestamps and guards that begin their shift and then fall asleep or wake up while they're on their shift. So it asks, find the guard that has the most minutes of sleep, and then it asks, of all of the guards, which guard is most frequently asleep on the same minute? And so people build all sorts of visualizations and diagrams of all of the things and like data analytics and like load these things into real tools that do like real analysis and stuff, which is awesome. And other people just, create funny GIFs of guards that dance around on a clock and then every once in a while fall asleep for a bit and then wake up again. Here's another puzzle that gives a list of walls and then it says water is going to start pouring into this 2D environment from the top here. How does it flow? Where does it fill up according to some rules? And that one ends up filling up in an animation like this, where somebody rendered it so that it actually shows the water like flowing into all of these containers as it goes through. And this asks like how many water ends up being retained in these containers when everything's done. Here's one that claims, it's not really, but it pretends to be, a regular expression that matches all of the paths in a maze. Which is a really funny time, and the solution actually involves not doing that at all, but treating it as a graph, basically. And so you get an input like the top, and you end up generating a thing like the bottom, and somebody built this animation of it actually going through and running the whole maze and finding all of the paths, and I love the stuff like this. This is great. I love all the animations. They're so much fun. Here's one that asks, what dots, or given these dots, what other positions are the closest to any given dot based on Manhattan distances, taxicab geometry? Here's one that is a 3-state cellular automata. This one was a lot of fun because I knew I wanted some kind of an interesting 3-state cellular automata, so everything can be white, green, or brown. It was, I think, clearing trees and logging camps or something like that. And so the trees grow, the green things, the trees grow over time into the clearings, and then the brown ones, the logging camps, like grow in behind them. And I ended up, just by fiddling with it for a while, coming up with a set of rules that in almost all of the inputs always ended up in these really cool spiral patterns. And so I basically wrote an input solver that, so the generator just says, here's some random noise, and then the solver says, make sure it ends up in a spiral pattern. So that way, no matter what, anybody that took their input and actually visualized it would get this really cool effect when they were done. Here's another one that says, here's a bunch of dots in 3D space, a bunch of points in 3D space, and they all have some position and some velocity. Where do they end up? Do they collide with each other? If so, where? And it ends up looking like this. So it's going to move, and then it's going to zoom in a little bit, and now you can see that they all like smack right into each other in the middle here. And somebody used, I think this is GNU plot, to figure out where they all collide, and then for the rest of them that don't collide, where they all go. Here's a graph of the first 100 people to finish each puzzle. I forget what set this is. This might only be a year or two, but I don't remember which one. But you can see kind of the typical amount of time that it takes to solve for 100 people, the fastest 100 people, which by the way are often a bunch of competitive programmers, so it's not really a good estimate of difficulty, but it is a good estimate of like how involved it is, maybe. Typically 15, 30, 45, the median there is what, 30-ish minutes. And then all of a sudden, every once in a while, puzzles take, an hour, 2 hours, 3 hours, just because they're more involved and people went to bed or people had to go to work or whatever, and so fewer people are doing it, so it takes the remaining people longer on average or something like that. But typically, I aim for puzzles that are smaller than that, hopefully. So let's talk about some growing pains. Let's talk about some learning experiences. How do you prioritize tasks? This is something that I had to figure out, because my normal method of prioritizing tasks is as follows. 1, thing happens, right? Whatever it is, something happens. 2, handle the thing. 3, go to 1. Great. As long as you have one thing at a time, everything is top priority, no problem. Everything is fine. How do you prioritize tasks if you have 730,000 users from all around the world of all different backgrounds? Well, it goes something like this. 1, the thing happens. 2, handle the thing. Great so far. 3, while you were handling the thing, several other things happened, but when you try to handle those things, even more things happen, and then you never sleep. Which is how I was for the first couple years of this. It is not the best strategy. So to resolve this, actually stop to prioritize things. Actually say, like, okay, is the site outage more important or less important than this email that just came in? Don't just handle the things in the order that you saw them. Get help from other people. I have a bunch of beta testers. I have people watching the site. I have people helping me run the community. I have an entire subreddit of people that helps itself. We have things documented on the subreddit wiki. We have, I've automated a bunch of tasks on the back end, and I've provided some self-service tools for some sorts of things. Basically just streamlining things and like stopping to think and stopping to figure out what needs to be done. Let's talk about accessibility. Accessibility is really important for every website. It is something that I take very seriously. We have people, even on just the beta tester or moderator team, that have different various disabilities. I have a disability. So accessibility is very, very important. Careful testing is a good way to get around that. Running it through the automatic checkers is a good way to get around that. And taking accessibility feedback seriously is very, very important. If somebody emails you and they say like, hey, I'm having trouble reading this text, like, it's not that that person is like wrong or bad or something. It's that your website is broken and you need to fix it. From my perspective, accessibility issues are as bad as outages. Some fraction of your user base can't use your application. That's an outage. So if you have part of your application that people are having trouble using because whatever reason, right? That's an outage and it should be handled with the same priority as any other outage would be. Let's talk about denial of service attacks. I do not know why somebody would try to denial of service attack a programming puzzle website, but we've had a couple in the past. Do not know why somebody would elect to use their botnet or whatever to do this, but they try to. Fortunately, AWS provides tools like just banning whole ranges of IP addresses, which largely solves the problem. If it's dropping the traffic at the load balancer, at like the virtual private cloud edge, and it's not getting into all of our resources that we're like spending money on and stuff, that typically works. Also, AWS is pretty good about helping people get around denial of service attacks. But yeah, you get big enough and you'll see it eventually. People just start throwing traffic at you because it's funny. Don't know. So here's some frequently asked questions. Why do the puzzles unlock at midnight UTC -5? Or why don't you make the puzzles unlock at a different time every day? You have 25 puzzles, you could make them shift by an hour every day. The reason for this is that it's when I can be awake to watch the servers and monitor the event. I can consistently be awake at midnight UTC -5 every single day and still have like a family and a job and sleep. If it's moving to a different time every day, I would die, and so would probably most of the users. It's untenable. If I moved it to some other time, I would be watching it, you know, when I would have been asleep, or when I would have been spending time with my family, or when I would have been spending time at my job. Like every once in a while stuff happens. Like I talked about before, we had some problems during the 2020 unlock. We've had problems in the past too. And so if I'm not around watching the servers and they fall over, like that's not great. So they are around when I'm able to help like watch things and run the event and fix stuff when it breaks. How long does it take to make 25 puzzles? I typically start in April, and they need to be done by December. So that's, 8 months or something like that? In that span of time, I need to plan the story, design the calendar, build all the puzzles, test everything, add features, adjust the hardware as necessary, scale things. The puzzles themselves take, right now, about 3 or 4 months of all of my free time every night, spread over 5 or 6 months, which is still most of my evenings. Just, researching things, writing puzzles, testing things, just all of the stuff involved in that we just talked about. It takes a while. Can I send you puzzle ideas? Please do not send me any puzzle ideas. If your message looks like it's a puzzle idea, I will ignore it and delete it. Or I will have somebody else scan it looking to see if it actually is a puzzle idea. The goal here is I don't want to accidentally steal your idea by reading it or skimming it or something and then using it later on without realizing it, not crediting you. I don't want to worry about attribution. I don't want to worry about copyright infringement. I don't know where your puzzle idea came from. If you got it from a game or some other copyrighted source, like I can't confirm that. So I don't take puzzle ideas from anybody. I only generate them for myself and the things that I find and I research, which at least keeps me safe from like legal problems and things like that. Please do not send me puzzle ideas. I have hundreds of ideas in a giant list. Why is the site rejecting my answer? Popular reasons are you're using the wrong input. Different users get different inputs. So if you're using your friend's input, you're going to get the wrong answer, probably. Or you have the wrong solution. Even if you're super, super confident that you have the right solution, if it's not like 3 minutes past midnight, a ton of people have already solved the puzzle that you're working on. It's extremely likely that you just have the wrong answer somewhere. You misunderstood something, or you have a bug or something like that. Another very popular reason is you didn't copy paste the whole answer. That's surprisingly common. People will copy like all but the last character of the thing in their terminal and paste it in, and it'll just say it's wrong and they don't figure it out or something. So make sure that you're careful about selecting everything. Typically those reasons though. What else? Does the site lock after getting a wrong answer? Or why do I have to wait an hour to submit my next guess? So this comes up occasionally. The site locks out for a minute after getting a wrong answer. And the reason for that is largely to prevent people from writing scripts that just spam answers into the site until they get it right. If you get wrong answers enough times in a row, it will start to lock you out for longer and longer periods, which is like that to prevent people from writing scripts that spam the site with answers very slowly. If you see somebody claiming that they have to wait an hour to submit their next guess, it means that they submitted a wrong answer a lot of times. The site doesn't scale up to like hour length waits for a lot of, I forget exactly how many it is, but that's not something that any normal user ever encounters. But yeah, it's something that comes up occasionally that people ask about. How do some people solve the puzzles so quickly? Or are the people on the leaderboard cheating? No, they're not cheating. They're just very fast. As we discussed in a couple slides back, the people that are solving the puzzles right at midnight are competitive programmers that cut every corner and take every shortcut and use every tool at their disposal. They have a bunch of algorithms already memorized. They have a bunch of tools already written. They eat, drink, sleep, breathe puzzles for breakfast, lunch, dinner. This is how they think and what they do. So they're not like opening up an editor right at midnight and like deciding how they're going to approach it and like skimming through the text and reading they don't do any of that. The approach typically is scroll to the bottom of the page, click on the download input button, look at the input, because the input is the only thing that really matters. Based on the input, does it seem like it's asking an obvious thing? Then go back to the puzzle and look at the last line, which is usually a problem statement. If that's enough to guess at probably what the puzzle is asking, go start implementing that, and while you're implementing it, skim through the rest of the prose to get any clarification you need. This is very, very fast. They're doing a lot of guessing. They are familiar with the kinds of things that programming puzzles can ask, and so they're working in a limited state space of like the kinds of things that the puzzle might be talking about, and they just do it all the time. There are a lot of videos and recordings of very high-ranking leaderboard people solving the puzzles right at midnight on like YouTube and Twitch and places like that. If you're interested in watching them and how they do it, it does not look like regular software engineering at a job. It's a completely different thing entirely, but no, they are definitely not cheating. They're just very, very fast. Let's do some stories. So here's one that I really like. This is somebody that just posted on Reddit. They said, as the non-participating mother of a 14-year-old who got up at 4:50 a.m., I'm both massively impressed that people do this and somewhat baffled that nothing else has this effect. I've been reading here on the subreddit where we talk about the puzzles so I can make sense of the conversation later in the day. So this is a mother whose 14-year-old has been getting up early in the morning to do programming puzzles, and the mother is like trying to make sense of what their kid is doing. It's just, I love that. I've gotten a couple stories like this. It's so funny to me. Or people that just say, Advent of Code helped me in getting my current job, or helped me with an interview I did, or helped me, whatever, gave me the confidence that I needed to apply for this position, or something like that. There's a lot of people like that, which is excellent. I'm really glad that people are able to apply it in that way. Or people saying things like, my son and daughter are becoming more interested in coding because of your site. Like getting to people that didn't necessarily know about programming or know how to get into it, but seeing these small approachable puzzles, and not like a big application, but just like build a thing that just, goes through this list and finds some things, and having that be the starting point for saying, oh, I can make computers do things. What else can I make computers do? Well, let's try some more of these puzzles, and just like getting more and more into it. I love that. There's also situations where people use Advent of Code as a midterm exam in university and as a final exam, which is hilarious. In conclusion, engineers in your organization should solve puzzles for fun. Actually, scratch that. Everyone should solve puzzles for fun. Thank you very much.